Python scientific stack. 3, the scientific stack.
Are you talking about NumPy?
NumPy?
Matplotlib.
Yep.
Yeah. Was used Matplotlib 1, 2. Once. So, Matplotlib. So I'm Majid. People call me Magic. I'm basically describe myself as a mathematical programmer. I use Matplotlib pretty much regularly. And the problem with Matplotlib is that it lives on my desktop. I hate that. So what if I want to share my Matplotlib with others on the web? So there's a few things you could try. You could try an IPython notebook. You want to know that?
Yeah.
It's great, but it's not interactive enough. There's some efforts here and there, or actually very recent efforts to make IPython more interactive. But for what I worked on, it wasn't good enough. And plus, IPython is basically it's basically a document format. And what I developed was pretty much you could consider an app. So, as a scientific programmer, I don't begin on web. I begin on my desktop. I begin on my Spider IDE and I type import matplotlib and then develop from there. How to get it on the web was a pain in the ass. So that's what I want to share with you. I can just share with you the end product. But the whole process of doing it is probably, I could probably talk about it for maybe 30 minutes. Okay. So, just, can we mirror the screen? Yeah, that would be easier. Okay. So who knows about GTK3? Okay, so it turns out that GTK3 is instrumental to being able to deliver an interactive Matplotlib on the web. So Matplotlib, the more simple use of Matplotlib is just to display a plot. But you can have it. It could almost be a GUI. It's got some GUI elements, but most people don't go there. I went there though. So I could title this talk Serving GTK3 on the Web, or I could also say I put Bayesian optimization as an app on the web. So this, I can click on this. So this window here, this began on my desktop. This is on my desktop. Was on my desktop. To put it on the web involved basically putting some kind of framework around being able to serve this as an application to anyone on the web to just click on it and then go, oh, pretty cool. So this is just the Bayesian optimization. It's not, my point isn't to talk about Bayesian optimization. My point is this is a interactive Matplotlib. I tried IPython notebook, didn't work. I tried different backends. So there were some different HTML5 backends.
So what didn't work in IPython notebook? What was the failure?
The failure was, so there are different backends you could use for Matplotlib, different HTML5 backends, and none of them supported clicking.
Okay.
That's all I wanted. That's all I wanted.
So these graphs are interactive, like scaling and zooming and panning?
No, scaling and zooming I think should be fine on pretty much any backend. So it's the more interactive stuff that had, had a problem. So here's how it works. Demo. Are there port blocks on network. Yeah, so if it doesn't connect, that means some ports are blocked.
That could be.
Yes.
My VPN does not want to connect.
So if it's just port 80, it's not going to work.
I didn't know there was another port.
But
There isn't, it's a lie.
So anyways, it's not going to work here. But yeah.
post a message to the meetup board so that we can look at it later, though. I mean, if you have more to talk about, please feel free. But we can look at it at home too. It's not a big deal.
Sure, I mean I can tweet it or.
Yep.
So this is a demo. I mean, so you have the ability to click anywhere here. Well, it's just a game I made for Bayesian optimization. It's a mathematical thing. I think I'm in the wrong audience here, but yeah. So for you more ops people, this is all the stuff that I did. Whoops. Yeah, it doesn't want to work. Yeah, ports. I begin with port 8000, it's not going to work. Yeah, it's not going to work.
Can you briefly describe how GTK3 fits in?
Okay, sure. So, I kind of documented my whole process here. So, GTK3, the great thing about GTK3 is that you can compile GTK3 with a web server, so that the display is the web server.
Ah, okay.
So basically, I made my application around that. Once I found that ability, then then I had the ability to serve it. But this this web server, it's kind of like for personal use.
Mm-hmm.
You know, it's like here, I'm gonna stuff the server on my computer. It's at this port, you know, and then it's very personal. I wanted anyone in the network, or even in this case in the world, to just click on this and then get the app started for them. That's what I wanted to do. And so I got into WebSockets, I got into Tornado, I got into Flask. Well, I started with Flask first, didn't work. Then I went to Tornado. Then some code to manage starting up and shutting down that web server because I didn't want to open all the time. And I still don't like it a whole lot the way it is right now. I mean, you can poke some ports and you can find my app, but I'm not a web guy, I'm not a rigorously trained software engineering guy. I just got something to work. So basically, once I found out about this web server, I kind of went into it. I took out the HTML5 from the web server, or HTML. So I took that HTML, I put it in my Tornado. So you get the HTML from Tornado, and that HTML will take you to the actual web server. I needed to do that, but that's what I did.
Okay.
It has some JavaScript. The whole magic happens in some JavaScript, so that there's a connection in the display between what you see on your screen and the computations happening on the computer.
So is it kind of like a VNC kind of thing where you're...
Yeah, it's smarter. I think it's smarter. So I don't know exactly what GTK3 is doing for the web server, but I think it's sort of like VNC. It might be smart, but if you go into this app, it's very responsive. I mean, it's I'm very, very impressed by how responsive it is.
So it's rendering GTK3 using Canvas, using OpenGL, or
HTML5.
Which is Canvas.
yeah, which is
Yeah.
okay.
Yeah.
I just
Maybe.
I'm still confused.
Yeah, GTK3 is just the GUI.
I mean, yeah, I know what it is. I'm just
My laptop is connected to my cell phone's hotspot if you still want to show us the...
So you've got your own...
Yeah,
Oh, is it working?
Yeah.
Oh, cool.
I do have my charger with me.
Oh, you don't have VGA though.
No.
Oh,
Oh, was it that? Oh, okay.
All of my boxes have reverse SSH down.
That's the power stuff, I don't really know how many I have until we send it that left.
Is it, well,
It's like there's power here.
There's power up on the wall there too.
Oh, yes, probably.
so just, I don't know how to work this.
Doesn't get touch events on iOS.
What's,
Picky, picky.
oh,
You can't close the window.
You're a jerk. That's all I can
how do
say.
I, zoom,
Just a point of information, that's all. I'm not
There.
complaining.
Uh-huh.
yeah, so it's, I can, it's, because it's a window, you can kind of drag it around. So you hit the, I hit the, this, it's pretty,
So you just click it.
yeah, it just goes, I mean, something's happening now between here, and it's going to the server, and coming back, it's like almost, to me, it's just almost instant. So, yeah, back to some infrastructure. So I had to deal with infrastructure because I wanted to put it on the web. I was thinking just directly, setting up a AWS and then going from there. But no, then I read about Docker. I just saw how impressive the technology behind Docker is. So it's, I began with the Docker. So once I wanted to get into production, well, in my production, I set up a Docker, and then I used a service that manages Docker containers across different infrastructures, which is, I wrote about it, it's like called Totem or something like that. So part of that service is you can have your Docker live on AWS. So you didn't have to deal with AWS directly, I just gave it to Docker, problem solved. After some networking configuration, but problem solved. Yeah, so it's just a little toy thing, just educational about Bayesian optimization. I don't want to get into that here. But yeah, so if you're interested in the code, at first I began, when I first started trying to deliver this, I began with only this thing as my concern, then I kind of generalized it. So I split my GitHub repo into what this is running off of, and then there's also some generalized stuff. So you can put anything that, any GTK application, you can kind of serve it. So, any other curiosities?
So
Can I zoom
what is the app doing?
Or I think there was.
Hit the green button at the top left.
Oh, okay.
If it's a
No, I need
canvas
to zoom
element, it's
the-
going to be fixed. And
Yeah.
Something follows Zoom.
Yeah.
Yeah, click that, and there you go, so.
Right. Okay. Yeah. So this is just want me to talk about Bayesian optimization or just play with that here?
So you can click on portions of
Yeah.
that? Oh, I see, yeah.
Yeah. Click. So there's some computations going on with every click. And too bad you can't have those computations on your web browser. So I had to set up a server because Python doesn't live on the web yet.
Did you look into the option of transcompiling into JavaScript?
Yeah. Give me NumPy and maybe I'll think about it. That's all I care about. I mean, it's using stuff from NumPy and SciPy. I'm
It's
using one
like-
function from SciPy.
I would say that would be an extreme move, but you have done something more extreme than that. So that's why.
I looked at.
Have you seen the video of the death and rebirth of JavaScript?
Yeah, it's all.
Oh, I was just on
Yeah,
the
yeah.
It's like eventually we're going to be running a web browser.
Yeah.
So I found the maximum, and then the computer won. So click. I mean, if I didn't have this clicking, it wouldn't be just as elegant. If I I don't want to use those controls in IPython, and plus, even if I wanted to use IPython, I'd still have to have a server running the computations.
So what does it mean that the computer won?
Oh, so the idea of Bayesian optimization is you want to find the optimum in the least tries possible. So that's the whole point of Bayesian optimization. So I've got this randomly generated smooth function. Just restart it. Oh, so a feature I had to implement is the application gets killed if you don't confirm that you're active on it in about 5 minutes. So that's, I had to do that. Or else I would have processes and server processes running all the time, which I don't want it to do.
Oh, so there's a dedicated Docker container for every one of these?
No, it's all in the same. It's all the logic of the displays is all in the same one thing, which gets into one Docker. So it says I disconnected because I refreshed. This is all WebSockets that's monitoring the connection. WebSockets is awesome. That's the reason why I used Tornado, because of WebSockets. I wanted to something to like ping the user, are you alive? So I had to play with some JavaScript to get that working, which is not my language. So yeah, I give you a 1 point, and you try and kind of guess where the maximum is. Oh, up there, up there, up there, or maybe here. Nope. 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 Where is it? There. So I won, actually. It took me 15 tries, while the computer took 18.
Wow.
So yeah, the computer was all over the place, so but I beat it this time.
Now you do like a genetic algorithm.
Oh well, yeah, I can talk about optimization, but yeah, you could do genetic algorithms for optimization, but genetic algorithms don't care about minimizing the number of functions you evaluate. So because I'm working with neural networks, and they are very, very computationally intensive, and I want to minimize the amount of time I spend on my neural networks. So Bayesian optimization kind of has that in mind. That's an objective. There, I won.
Yeah, yeah.
That was cool, thanks.
Sure.
I can't steal the adapter, that's cool. Who uses Sublime?
Yeah.
It's like the world's best.
Why do you even need to?
It's awesome.
I just really.
Because it has freer colors.
There is Sublime, or Vim bindings for Sublime if you're interested.
It literally is like the first, if I'm trying a new IDE, the first question is, does it support
Neovim
Vim bindings? The answer is no. I'm like,
I read posts for NeoVim, but I'm still on Sublime.
oh. Can you guys read that at all?
You can
No.
zoom in.
See if that'll.
See it fine.
Yeah. Okay. Cool. You guys need glasses. Huh?
All right, so ignore what my company does for a little while. As a part of what we did, we built a system that we call event-driven infrastructure. So the idea is that our system is continually harvesting the cloud provider, Amazon, Rackspace, OpenStack. We actually do support all different APIs and provide a unified API. Side note. But we harvest that data continuously. We take all the data, we shove it through a unification engine. We end up on the other end with this unified model of what security groups look like, what load balancers look like, what instances look like, so on and so forth. The UI was really slow, and so we wanted to, that's why we did that. So we wanted to store all the data locally, so when people interacted with our system, it was very snappy, and it wasn't going and asking Amazon every single time we wanted to do something. So that was the first mistake that turned out to be awesome. The second mistake was that we didn't want to write to the database every 30 seconds when we were harvesting data from Amazon. So we diff checked everything. If there was a difference, we wrote it to the database. This ended up with this sort of unique system where we were constantly interrogating Amazon and checking for changes in your environment. So server stopped, Elastic IP changed, new load balancer, security group has been modified, new rules there, whatever it is. And when we do the diff check, we put Python decorators for hook points. So when something changes. So in this environment, what we've done, and we're talking about open sourcing this, which is why I'm sort of showing it off. We're just not certain what we're going to do. We're going to open source it or just give it to the community in like a package because we don't want to deal with an open source community. But what it comes down to is that we built these hook points, and you can see this decorator here is on divvycloud.instanceModified. So that piece of code will get fired anytime an instance is modified in your environment. So if a IP, Elastic IP, is disassociated or associated to it, if the state changes from running to stopping. This scheduler that we have is actually reasonably intelligent, where it will actually determine when to harvest data based on the state of the system. So transitional states will harvest it faster. So if the system is stopping, we'll start to harvest that data faster, and when it hits stopped, your Python code gets fired. If a security group gets modified, someone adds a new rule, your Python code gets modified or fired. So we see people using it to do things like, hey, let me check this rule just got added against a blacklist. If it's in there, because we have the unified API element, if we detect a rule that's not supposed to be there, it just gets deleted. So if port 22 is not supposed to ever be open to the world in your production environment and it shows up, it gets deleted. And it happens sort of autonomously. Sort of dangerous in some of the things you can do. In this case, what we're doing is using a Python decorator to check the tags on the system. And we're looking to see if there's an environment tag, a key. And if there is, we have a concept that's like Amazon resource groups, but it's cloud agnostic. So if the key is their environment, we look at the value, production in this case, and we put it into the production resource group. We then have a second decorator on here, it's resource group modified. So when a resource group is modified, this code gets executed. So you can start to chain together a series of events. In this case, what we're actually using is for Ansible. So this first thing, new system comes, this is the text, a brand new system has come online for us that's modified from pending to running. We check it through the tag, we put it in the right resource group, and then down here we're saying, oh, that resource group has been modified, or a resource group has been modified. We're going to look at that particular resource group and we're going to go run Ansible scripts against it. Now this is just a generic example. You would obviously check which resource group got modified. But the idea is to be able to create a system where if you change the tag on a server from staging to production, for example, it will actually mutate that system to the next layer, whatever you need it to do. It could then go in and make security group modifications, update a load balancer, whatever it is you need to do, because the system can actually see load balancers, RDS, instances, and everything. We're trying to drive it all through Python, as opposed to doing it all ourselves, because we're sort of lazy and we'd like everybody else to do it for us. So we decided to build the system. The other things it can do, this is kind of fun, Elasticsearch plugin. This little set of code here will dump a JSON representation of the instance into Elasticsearch every time it's modified or created or terminated. And that means you can actually have like a Kibana board tracking your environment as it changes, like number of running instances, stop instances, new security rules that have been added in the last hour, all the things that are occurring sort of on a regular basis and very organic. And this one is our favorite. This one uses Slack. Every time something happens in the environment, it just updates our Slack channel. So in this case, we'll be doing for everything, which is really annoying. But we do, presumably for production, system has been terminated. So the question I have is, we're thinking about giving this piece of what we've done to the community and seeing if there is use case for it. We found tons of use cases. Things like one of our larger customers uses it to check for a billing ID tag on the server. If there's no billing ID tag on the server, it terminates it. And so they can sort of make sure things are supposed to be the way it is. With those use cases in mind, are there any other use case people can think of? Is this interesting? Would the community use this? Could you do orchestration? So I open to the floor. Any comments? Thoughts? Is it cool? Not cool?
How do you introspect on it? Like how do you, I mean, I noticed that you have logging in there and stuff, like when you're trying to see what it's doing, like do you go to a log and look, or are there tools for sort of viewing it?
So you can do it right now, we just do the log. The way the system works is we have a different set of distributed workers. One set of workers are specifically set to execute this kind of stuff. So you could actually attach, like you could run one under PUDB or something like that if you need to step through a particular function set. But otherwise we rely on logging to do a lot of that. Although PUDB is awesome, so if you haven't used it, it's amazing. Can anybody think of any ways they might use this?
There might be a security element here. I've dealt with, at a previous employer, someone decided to publish our Vagrant VM without changing the default user password.
Never happened.
And we discovered there were some instances running on Amazon we didn't anticipate. So in that circumstance, I could see some kind of notification for then hooking to those the hooks that AWS doesn't provide. Some way of escalating certain actions we may see as threatening or otherwise malicious.
Yeah, I was going to ask, like, is the added value over like AWS config and CloudTrail just that it's cloud agnostic?
Works on OpenStack, VMware, Rackspace, Azure. We just added Azure. Google, Amazon. So if you think about like resource groups, we're going to be abstracting load balancers as well. So the load balancers will work agnostically. We already support like the native load balancer. We're actually going to abstract it using like a Nginx or something along those lines to allow you to provide load balancers in multiple clouds. RDS is just automated MySQL. The idea for extracting databases is run the master in AWS and a slave in Google. So if anything crazy happens, you still have your slave replicating that entire time and all is good.
So within AWS, is there any benefit over using this rather than CloudTrail or config?
So other than we do allow you to put in multiple accounts. So you can put like 20 accounts in there and we will track changes on all of them simultaneously.
Okay.
We also have visibility into the operating system if you let us have it.
Okay.
So we provide an agentless connection mechanism in there. What we do is we're talking in the lobby, we SSH in the system and immediately start a Python interpreter. And then we actually start the Python interpreter as a non-buffered Python interpreter. And then we turn STD and STD out to binary channels. And we actually create a socket connection of sorts for reading and writing over. And we start seeing down Python code loaded into memory and execute. So there's no footprint. But it is, and every time you disconnect and reconnect, it's the whole new version of everything that was there. It takes a little longer to get running. The nice part about that is because we're doing it that way, we can actually provide Ansible a transport that doesn't disconnect. So one of Ansible's big problems is it's constantly, every time it goes to do stuff, it has to recreate its SSH connection. We started doing that, and because the only way to get SSH multiplexing was to use the native SSH implementation, which we didn't want to use, we wanted to be Python driven if we could, we created a connection to the system, and since the Python interpreter is running, SSH connection doesn't die. And then we basically created the channel along that. So we started being able to pull back operating system information like packages installed, CPU, memory, and all of these hooks exist for those same things. So if a new user is added to a system, it'll fire a hook. If a new package is installed in the system, it can fire a hook. And you can sort of check for those things and use Python to, what we call event-driven infrastructure. The whole thing should start from some guy pushing start on a Jenkins build, which then creates this whole sprawl of effect where the entire infrastructure gets built based around that. Is it completely insane?
No, it's interesting. You can probably start cascading things. You say, okay, I want to start with, locking down my root password or something like that, and then, you can actually do loosely coupling instead of one giant bash script.
I mean, that's the idea, is to build sort of function-driven, event-driven changes that cascade across the entire environment because one thing happened. What we want to do is take it to the next level because we can see the load balancers, we can see the databases, we can see the system and the infrastructure, security groups, we can see and onto the system. All of a sudden, you have a full picture. And so if, like, for some reason one server's CPU goes to 100%, but your database is okay, your load balancer's fine, the system using something like this would automatically snapshot that system, move off to the side, and spin up a new system in its place. And ideally be like, all right, production is okay, go figure out why that happened. Something along those lines to allow the system to autonomously start solving problems based on events that are occurring.
This is probably me just being stupid, but is there anything like you basically in the you had this example where basically where you did action in this thing that caused the next one to cascade from it. Is there, and you could of course have a cascade loop. Is there how do you stop an infinite loop, or are you just screwed?
Fantastic question. I don't know yet. We are working on things along those lines to make sure that because you can trace Python code stack using inspect. So we are working on ways of being like, okay, let's make sure that we haven't just come through ourselves like 6,000 times. But that's going to be a very challenging problem for us to solve. Another problem is, Python's not like good at threading. So the challenge here is that this code right now runs inside of what we call a harvester. As I said, we're working on the piece that actually runs it in a separate process. But the challenge is it's single-threaded. So if this guy connects to Ansible, every job that's queuing up behind him isn't getting done because he's waiting on connection. So we're working on ways to keep that from happening. But since threading in Python is non-existent, in traditional sense, it's going to be challenging. We're ending up with like this queuing mechanism where it's like, I want to do that, put it back in the queue, put that, oh shit, and just, it's weird.
I mean, you could put that on some of those packages that do the queuing for you.
Yeah, we do. We use Redis and we actually use RQ. A heavily modified version of RQ to handle the queuing. But you still end up with like this, and you could end up with this infinite like, put job on queue, do job, put job on queue, do job, and just keep going. So we don't know yet.
Was the diffing that you described, was that hard or easy or?
I drink a lot of whiskey, so. No, it wasn't actually that bad. The hardest part was unifying the data. Getting it to, so the company was founded by former game developers, but we all were previous sysadmins. So sense the question I asked about. It was not biased, I promise. So we sort of understand infrastructure pretty well. So, but unifying it, like Azure sucks really bad. They've decided they have a whole new way to view the world, and so unifying that into a similar model like Google uses and what Amazon uses was really challenging.
Seems like there could be a lot of value in that, right? And sort of like talking about how you did that.
Absolutely.
Independent of the software almost, right? Like as a kind of like a micro standard kind of thing, you know.
We use, so there's a project out there called libcloud. It's an Apache project.
Right.
We contribute pretty heavily back to that.
Okay.
When we found that we originally started doing all our stuff on Bodo and like Azure's, well, Azure didn't have a Python implementation, the Google stuff and so on and so forth, and we quickly realized that was going to be completely unwieldy. So we ended up looking at libcloud, but libcloud was not at all built out. It could do Amazon pretty well, and you could like list servers in VMware, and that was it. So we received our funding a couple of years ago, and then just been like sort of fixing that up. Not all of it, because we do have to make money. Like we haven't given all of it back, but most of it. So I mean, at some point, if you guys are interested, happy to do a talk on just the Python madness that went on with that. Yeah, it was fun. I enjoyed it.
Come see me afterwards.
Our VCs are really pissed off. Like, what have you done for the last 7 months? Oh, you guys will love this. Not making any money. But,
First project's in great shape.
that's right. Yeah, but Apache's very happy. I guess is there any questions?
I was just going to say this probably is useful for us, or something of this nature is useful for us because we sometimes give people that we don't trust very much root access or access to like server groups, and we just want to see what they're doing. So I don't know if this would allow for that, but it's the same. I mean, you could just ping it into a head pattern, so I could see what the producers, and we give them some servers, or we give them a server group. And,
Yeah.
Just to audit that, I think there's some other tools that allow that kind of auditing. It's just kind of like watch directories and things like that change. But this would be anything that they would do in that.
We actually talked to a security consultant. I guess there's some sort of rating system that you can run on a system to tell you how compliant it is with the central intelligence, the intelligence community. You know, they'll give you like a score, like 80%. And someone wrote a quick plugin that deployed that in the system. Every new system that got spun up, it connected to and ran that, and the score was lower than like 80%, it terminated the system. And so you're like, well, that's pretty aggressive, but cool. What was really interesting was when the customer used that piece for the billing code mechanism, they basically were like, look, engineers, you can use Amazon. Go to town. Go to Amazon console, go crazy. It's fantastic. And then they wrote all these plugins that basically undid anything that got did that wasn't supposed to be did. So the billing ID, like the engineers got really frustrated because they'd spin up a server and it would hit pending state and it would go terminating. And they'd be like, what's going on? And it's like and they get an email, it's like, you forgot a billing code. Please try again. And it's amazing how fast you can get engineers to be like, fuck it, I'm just going to write a Python script to do this and it'll just be there all the time. And then the CFO's happy. He gets what he wants. It's something we call policy without governance. So similar kind of stuff, like just let them do what they're going to do and let the system take care of putting shit back into place as it should be. Sort of the ops guy that you were describing, except he's Hal. And he kills less people.
What's your body count so far?
Well, me. So these are the resource groups I was describing, actually. We can, I was just showing them sort of as a side note. When you move those instances into a resource group, it actually does a full dependency tree. So if you wanted to, it'll grab the security groups that are associated with that resource, the volumes, the snapshots, everything that's associated with that, and drag that and put that in the resource group as well. So in that example I had earlier with the Python code, okay, this one I'm not doing it, but you could with a function call, just go yes and dependencies, actually a flag. And so later, when some ops guy is looking through the stuff, he will actually see all the security groups that got moved over at that same time. And then we got, let me show this real fast because I think this is interesting. For the networks, yeah, dependency trees. This is not going to work for this particular one. Let's go find one that actually has stuff attached to it. There we go. This has instance using this network. So dependency trees, there you go. So we use this a lot, and what we do with our customers is when we go into a rat's nest environment, we can actually build a dependency tree about what one VPC has and everything that's in it and associated with it. You can do this for any one of the resources, like load balancers and that kind of stuff. It's kind of fun. But I'm getting into the product. I'm going to stop that.
So will that do dependency trees on your application services?
Next.
Okay.
That's why we started investigating Docker. So we will be doing, while it is very cool, it has some serious deficiencies in networking and other areas. But we will be doing some deployment mechanisms around similar to CloudFormation templates, but they're cloud agnostic, and then they use like Docker and that kind of stuff. So when you deploy them out, it's really interesting is when you have all the data, like you have all the security groups, and you have all the data about it, you can actually start to do some interesting things where I now know all of the ports you have opened and what systems are allowed to talk to what systems. So this system just got compromised. Show me all the systems that this system can hit, and then show me the next layer of, oh, this system is 3306, can talk to that system. So technically you could have made a jump if you were smart, and so on and so forth, and sort of go out. We're going to do very similar thing in applications. Sort of like this system is running this application, and we know that it's using that load balancer, which means we know it's also with these applications. And we know that because the security groups associate them, so the ports that allow them to talk to. So it's really weird. Like once you get the data in place, you can just really start churning through it and do some really cool stuff. It's part of why we're so excited is because once we realized we had all this data, we were like, shit, what can we do with it?
It's kind of like F8 for like.
PEP 8 for the cloud.
You're right. I mean, you're like, make sure it does what I want it to do.
You'll note that I don't have PEP 8 enabled.
Yeah.
But yeah, no,
I already do it all.
it is very much, it's a different approach to seeing it. But the cloud just changes too fast. So as opposed to trying to get in the way of engineers getting to use it, just train them brute force style on how to get there. By the way, we're like seriously hiring Python developers. So if you guys are, the next layer of this is, we'll be doing some artificial intelligence stuff where we want to take all that data and actually have this system making decisions about what's going wrong and start fixing it, which will be really cool. I'll be really interested to see if everybody uses it because it's scary as shit, but
It really will be how.
it will be. But the idea is to manage. I mean, when we were at EAA, I had 2 teams working, one in Austin and one in Fairfax. The Austin team had 4,000 physical servers. They had 40 people. The Fairfax team had about 3,000 physical servers, and they had 4. And the primary differentiator there is Python. The entire team up in the Fairfax area all knew Python, so they automated absolutely everything they did. And when shit was going wrong, it was automatically fixing things and it was doing things, and you began to get this sense of like, 10,000 servers really could be managed by 2 people if the system is doing what it's supposed to do. But yes, we're hiring. Please. Seriously, I've been waiting for months. Like, any other questions? Cool. Thank you guys.
No. Yeah. No, I'm job hunting, but I'm not a Python developer.
We have a job hunter here who is not a Python developer.
So, I'll save it for...
You didn't save it, you just... Too
No,
late.
no, I mumbled it to...
All right, fair enough. Anyway, that's it. Thank you all for coming. So, depending on what the stupid weather is outside, typically we retire to the bayou, which is actually half of a quarter of a block this way, and then another block to the left, and then a quarter block to the right. It's on Pennsylvania. Thank everybody for coming. Let's give another round of applause to our speakers. Thank you. Oh, and come to me if you want to talk.